here with Chris Smith from Microsoft. Chris, how are you?
Oh, great.
It's great to meet you. I've heard your name many times.
Hopefully in a good context.
Absolutely, absolutely. What's your job?
I am a software design engineer and test on the Microsoft Visual F# team.
Visual F#. You're not going to believe this, but I've never written a line of F#.
That's okay. A lot of people are in that same boat, and maybe that'll change one day.
I hope it does, but tell me, what is F#?
Okay.
Is it really called Visual F#? I've never heard it called that.
I think marketing folk, it's Visual F# on the box, but we just say F#.
Is there a non-Visual F#?
No.
Okay.
No. I mean, it's just the language. But really, what in a nutshell, what the programming language is about is right now there's C#, VB, Iron Python, Iron Ruby, any number of other programming languages, right? But primarily on .NET, it's mostly C#, VB.
Yep.
And these are great languages. They do a lot of great things. There's a lot of fantastic libraries and tools and whatever. But for some people, they're not having a good time. They're writing.
What's wrong with these people? How can we help?
Well, we're trying to. So the problem is sometimes, particularly in say quantitative computing, data-intense sort of applications, right? An object-oriented language like C# or VB, the problem is that you're struggling against the language. If you want to focus on algorithms or computation, in an object-oriented language, you have classes, you have interfaces, but not functions. Okay, and so the problem is that
we have methods.
You have methods, but the methods are always associated with a class.
Yes.
So maybe you create a static class with a lot of helper functions associated with them.
Okay.
And this is because you're in this object-oriented programming paradigm. Whereas functional programming and F# are about thinking about programs in a different way. So although it can do object-oriented programming, you can create classes, you're using lists, you're using discriminated unions, tuples, records, these sorts of new functional programming constructs that it's what the language offers, right? Is a different way to think about programming and different tools for writing code. And for some certain domains, you're going to be more productive doing that. Because the analogy I use is, if I try to throw you a football and you have oven mitts on, you can catch that football, but it won't be very easy, right?
Right.
But if you have, say, football gloves, right, where you have all your fingers, it's much easier to catch that football.
Okay.
However, if you're trying to catch a baseball with football gloves, that's not going to help you out, right? You'll want a big actual mitt.
Okay.
Does that make sense?
That analogy definitely makes sense, but you're still using a lot of words that I don't understand.
Okay.
And so can you tell me a little bit about the language and what it is, what it looks like? What does a program written in F# look like? And
So-
why is that better for certain problems?
Okay, so imagine a C# program, right? 100 lines. So we're going to convert the C# code to F#. All right, step one, cut it in half. So the same 100 lines of C#, you can probably fit it on 50 lines of F#. Okay? Because the language is more terse. And by that I mean that it takes fewer characters to actually express sorts of things.
Is that because you don't have to instantiate any objects?
No, you do. It's just that it's a type-inferred language. So similar to the var keyword introduced in C#3, if the compiler can figure out what a type is, it will do it for you. So if you say, let f of x equal x plus 2, it's going to figure out that since you're adding 2 to x is an integer. Okay. And since the last thing the function did was, the body of the function was just x plus 2, then it just returns that value. So you don't need a return keyword. It doesn't have semicolons. It doesn't have curly braces because F# is also white space significant.
Okay.
So if you have a for loop and it's all tabbed in for spaces, then the compiler will be like, oh, that's the body of the for loop.
Okay.
It's kind of hard to explain, but the point is that if you're writing a lot of code that, such as extra classes, semicolons, curly braces, all these extra things that have nothing to do with the problem you're trying to solve, right? They're all about writing code for the sake of getting something done. But sometimes the amount of code that you have to write is much more than you would like.
Well, I would agree with that. So I guess the argument I always have is that I don't really care how much code I have to write, but I do care how much code I have to read. Because I read code a lot more than I write code, even my own. And so is F# more or less readable than, say, C# code, for example?
It depends on how you define readability, right? I mean, you can
In your
write.
opinion, I guess that's what that's.
I would say more readable in the sense that more code is fitting on the screen. It's easier to see what's going on.
Okay.
If you start renaming the parameters to your functions like I, J, and Q.
Or it'd be even shorter still.
Yeah, it's
That'd be
even
very terse.
shorter, but I wouldn't say readable.
Right, so terseness is not a goal in when I write code.
Yeah,
necessarily. Readability is a goal.
and it isn't for F-sharp programming
Okay.
too. So when you're programming in a functional language, sometimes design, like typical traditional design patterns, fall by the wayside because the entire pattern is obviated by the functional language, meaning that it already exists in the language or it's much easier to express.
Sure.
So for example, let's say you have a tree-like data structure. Okay, so perhaps the social network of you and your Twitter friends or something. So maybe you'll have some sort of object-oriented hierarchy where you have a root node and then maybe a bunch of classes that inherit from that node type, and then you're given a tree. So that root node has its children, and then you'll have to cast it as the specific node type. And it's just a lot of code, a lot of overhead.
Okay.
Whereas in F-sharp, you would use what's known as a discriminated union. So for example, if you want to represent a binary tree in F-sharp, you say type node equals empty or node of tick A node, meaning that if I give you an instance of a node, it's either empty and has no data, or it carries a piece of data and it's two child nodes.
Okay.
And so it's really hard to do this without a whiteboard.
I understand.
Oh yeah, let's go for it.
We have a whiteboard here.
Yeah.
Do I have a marker though?
Let's find one.
Yeah,
We're on the case.
All right. Follow me.
Oh,
we found a whiteboard.
All right, we
here.
are in front of a whiteboard. So here's what we're going to do. I'd like to show you how this elegant, terse syntax will actually help you be more productive in certain domains, okay?
Okay.
So the claim was that if you wanted to have some sort of tree-like data structure in C#, you'd have to write a lot of code. It'd be tedious and painful and difficult to maintain, okay? What I'm going to do is kind of write some C# code to demonstrate the problem, and then I'll show you how to just write it much simpler in F#. Sound it?
Go ahead and write it. Don't say anything. I'm going to speed the tape up, and through the magic of video.
All right, sounds good. So the problem that we're going to try to solve is, imagine I asked you to implement a virtual machine. So you wanted to have instructions of different types and execute those on some sort of hypothetical computer. So you're going to have various types of instructions, and each of those instructions is going to have a certain operation that it performs. Make sense?
Yeah.
All right, let's have at it.
Write code.
All right, so let me just walk you through quickly what this code does. So we've created two classes to implement our virtual machine, and these two classes actually implement just one instruction type. So first we have a class titled instruction. This is an abstract class that just defines the root of all possible instructions. It has just one virtual method, execute, that given an array of values represents the computer's memory. So then we create a class move instruction that inherits from instruction. And what this does is it adds some data associated with that instruction. So a move instruction has a source address and a destination address. And so in execute it says memory at the destination address is equal to the memory at the source address.
Okay.
So nothing too technical, but notice that I had to create two classes, some extra code, and then if I wanted to say execute a list of instructions, I would just call the overridden execute method. And so if I wanted to have an add instruction, maybe a subtract instruction, a jump instruction, I'd be creating a lot of these different classes. So let's see how in the same amount of code that we can create a more powerful virtual machine in F#.
Okay. You want to do it here, or you want to go over here?
We'll just do it right here.
Okay.
All right. So, in about the same space of code, we've written a more F#-centric solution. And in doing so, showcase some of the unique features that F# has over, say, C#. So rather than using classes in the object-oriented approach, we'll use what's known as a discriminated union. This is a type in F# that we're going to call instruction that is guaranteed to be only one of a set of values.
Okay.
This is also known as a sum type in other languages. So the first type of instruction we'll implement is called move. And then we're going to associate some data with this instruction. So move of int star int. So that means there are two integers associated with that instruction.
Okay.
So an instance of move is of type instruction. But if I give you an instruction, you know it's only one of these possible values. So similarly, I'm going to have an add instruction. And the way this is set up is, I have a left-hand side, a right-hand side, and maybe a destination register, right, where I want to place the value. Or I have a jump instruction that has an integer, an address to go to.
Okay.
And finally, we have a no-op instruction that doesn't have anything associated with it. So notice how there's this of keyword, we associate some data with it, no-op has nothing.
Okay.
So in just 5 lines of code, we've declared 4 different instruction types, each with associated data, all without needing to declare classes, curly braces, declare a bunch of fields. It's very simple.
Okay.
So down here we have an execute method. So we're going to define a function that takes an instruction, again, some amount of memory, and rather than using virtual methods to provide a specific implementation for each type of instruction, we're simply going to use pattern matching.
Okay.
So what this does is it matches against every type of instruction, and so if it's a no-op instruction, do nothing. And this is done through 2 parentheses, which in F# means unit, which is essentially a manifestation of void or nothing, right? Similarly, if we encounter the move instruction, what we're going to do is pattern match and capture the source and destination registers, addresses associated with the move instruction.
Sounds a lot like parameters being passed to a method. Is it analogous to that?
No, not really.
Okay.
Because what happens is we defined move to always be associated with 2 integers.
Okay.
And so we're saying this move is associated with these 2 integers, just name them source and destination.
Okay, and over here on the right-hand side of your area, you're doing something with them.
This is, and if the instruction was a move instruction,
Okay.
here we execute it.
Okay, take one step back to the camera to see that. That's good. Just want to make sure.
So in this case, we find the the instruction, capture 2 values, and then we update the memory at the destination is equal to the value of source. Assignment in F# uses this back arrow operator. And then,
Does my keyboard have that?
no, it's,
Less than dash?
exactly.
Okay.
Similarly, if we wanted to implement a jump instruction,
Okay.
we could do that. We could also implement add, and so on.
Okay.
And so here's a big benefit of using kind of the F# approach over, say, C#. Because previously, in the C# implementation, if you wanted to add a new instruction type, you would create a new class that, say, inherits from instruction and so on.
Okay.
In this case, if you added, this is guaranteed to only be one of these 4 types.
Okay.
And so whenever it's in a pattern match, if it doesn't execute on every single possible value, you'll get a warning that it's an incomplete pattern match. So this is actually provides an extra degree of safety in the language.
Oh, we get that at compile time?
Yes,
Okay.
at compile time. Right, because you don't have to worry about null checking for any of these.
Okay.
And in the C# world, if you have a class or an instance of a value, it could be null, it could have a value.
Right.
In F#,
But here, by doing these pattern matches, by defining none of these as having nulls, we're essentially guaranteeing they will not.
exactly. And this is just one such case where it's much easier to create tree-like data structures in F# than it is in C#.
Okay. Good. That makes more sense to me. When I actually see code, that makes a lot more sense. So what part of my application would I use? Would I build an entire application just using F Sharp, or would I have maybe a C Sharp application that calls out to F Sharp at certain times?
More likely it's going to be the latter.
Okay.
Right. The way I kind of say it is that if you're happy with C Sharp or Visual Basic.NET, just use Visual Basic.NET or C Sharp or whatever, right? Because those languages are useful, you're being productive, that's fine. Mm-hmm. But there are sometimes, maybe in that, that little corner of your application where it does all the number crunching, all the graph traversal algorithms or processing some data set to mine it for certain forms of information. And in that part of the code, you can be much more productive by writing it in F Sharp. You don't have to worry about writing a lot of classes and code that just kind of supports the algorithm that you're writing.
Okay.
In F Sharp, this functional programming, you're just writing the functions to do that computation. And because it compiles down to IL, it's just another .NET language, the C Sharp code can interoperate with it seamlessly.
How does that interoperate? So I have if I use this sort of heterogeneous approach that you just described,
Mm-hmm.
I've got a C Sharp application, and inside of one of my business object classes, there's this computational thing I have to do. I want to write in F Sharp. Do I add a new project of type
Yes.
F Sharp?
Yep.
Then I add an F Sharp module or something to that?
Yes, you would create an F Sharp library project and just add a project-to-project reference within Visual Studio, and
Okay.
things just work.
So from C Sharp, I create a reference to my new F Sharp project from my C Sharp project, and then I have to have a line of code that somehow calls how it calls execute, and
Yeah.
passes in an instruction, right?
Yeah. Yeah.
What does that code look like? C Sharp
This code?
What does the C Sharp code actually call execute?
So execute would look something similar to VM instructions.execute.
Okay.
This would just be a static method on that class.
Okay, all right.
Because F Sharp's compiling down to IL, which represents a lot of these functional constructs as classes and static methods, just like you would write them in, say, C Sharp.
Okay, all right. That makes a lot of sense to me, because I think that's a pattern a lot of people figure. They'll hire an F Sharp developer to come in to write the really hard computational stuff, and then they'll have to consume it. You're saying that consumption is just as easy as consuming C Sharp?
It's just like consuming, another .NET assembly that was written in, VB.NET.
Okay.
It could, look a little strange if that library is surfacing some of these functional concepts and constructs, because those aren't in C Sharp or VB. So the C Sharp or VB would look kind of strange. However, in F Sharp, if you just create a class, right, something that every .NET language kind of understands natively, then you wouldn't even be able to tell what
So you create
language.
an abstraction layer to hide all this F Sharp goo from the C Sharp developer.
Well, yeah, and it's mostly just because the way you want to communicate is abstract all the specifics of that functional code in the functional language, and in the interface that you want to communicate with the rest of your application.
Should be as simple as possible.
Yep.
No question about it. If I wanted to learn more about this, where would I go?
I have two answers for you. The simple answer is buy my book.
What's your book?
Programming F Sharp, due out by O'Reilly. It'll be in stores in November. That's the simple answer.
Right.
But really, if you want to learn more about F Sharp, just play around with it.
Okay.
Currently, the latest release is the May CTP. It's an add-in for Visual Studio 2008. It's about 20 megabytes. And you can just type some code, and just start playing around with it. There's a lot
Where
of...
do I download that?
fsharp.net is the F Sharp Development Center on MSDN. And also on fsharp.net, you'll find a lot of blogs and video presentations and tutorials, and just really, because a lot of people are in the same boat as you, just trying to learn more about F Sharp. And so there are a lot of good kind of intro tutorials available.
Okay.
But in November...
And so the book is one great way. What's another great way to learn about Chris Smith?
Well, I have my own blog at blogs.msdn.com/chursmith, CHRSMITH.
Okay.
And on my blog, I focus mostly on what I call F Sharp Zen, which are just little snippets, something like this, that show the how expressive you can be in F Sharp. Although I plan a new blog series as soon as I get back from DevLink, that should be awesome.
What is it?
Oh, well,
Let's teaser.
Yeah, I guess I can be a teaser, but
Yeah.
by the time this gets posted, so the plan is that I'll start a new blog series on awesomeness in F Sharp.
Awesome.
And the point is that, I can say F Sharp's good for computationally intensive domains, but that doesn't really resonate with a lot of people because they don't see it. And so what I'd like to do is start blogging about how to use the system.speech APIs to do voice recognition and show a good end-to-end example of that.
Okay.
Or use the OpenCV library, which is an open source computer vision library, how to use that in F Sharp. And actually do some of these cool projects that F Sharp would be well suited for,
Okay.
and just provide a lot of good examples for that.
Oh, outstanding.
Yeah, so that's the plan. I just need to get back to my office and start blogging.
I won't keep you then.
Oh, yeah. Well, thank you
so
very much.
I learned so much today. I
Yeah.
really appreciate you taking the time.
All right, thanks.
Thanks a lot.
An obsequious friend is one who waits on you with technology.